Hello everyone, my name is Brian Wilkins and this is my YouTube teaching project as for Math for Teachers 2. And today I'm going to be teaching you about pure mutations, part of the fundamental counting principle. Pure mutations with like objects and with unlike objects. So the fundamental counting principle is used to show how many different arrangements would come from a certain sample size. So say you are coaching a team and you need to pick 2 team captains out of a group of 20. You would first take the number of the sample size 20 and multiply that by the sample size after you take one captain out, which would then be 19. Multiply those two and those would be the amount of arrangements you would have for co-captains, the amount of people you could have combinations for co-captain. So let's go over first an example problem to show pure mutations with unlike objects and to show pure mutations with like objects. So for unlike objects, let's say, for example, Johnny's dad was cleaning out the attic. And when he was cleaning out the attic, he found a box filled with 30 batteries. He wants to see if the batteries will work, which different arrangements of the batteries will work. So he can keep those arrangements and then throw out the arrangements that don't work with each other. So let's set up this problem. So first we have to set up our sample size, which is 30, and set that on the paper. So we have 30 batteries to start. When I take out one, then I need to pick another from that sample size of 29 now. So I'm going to multiply 30 times 29. And when I do that, multiply 0 times 9 gives me 0. 3 times 9 is going to give me 27. Drop a 0. 2 times 0 is going to give me 0, and 3 times 2 is going to give me 6. Now we add them together. 0 plus 0 is going to give me 0. 7 and 0 is going to give me 7. 2 plus 6 is going to give me 8. But then, I need one more battery because the toy requires 3 AA batteries. So, then I'm going to pick from the sample size now, after picking 2 batteries out, of 28. So I need to multiply 870 by 28. So 0 times 8 is going to give me 0. 7 times 8 is going to give me 56. And 8 times 8 is going to give me 64. Plus 5 is going to give me 69. Drop a 0. 0 times 2 is going to give me 0. 0 times 2, 7 times 2, is going to give me 14. Carry the 1. 8 times 2 is going to give me 16. Plus 1 is 17. Now we add 0 plus 0 is 0. 6 plus 0 is 0. 9 plus 4 is 13. Carry the 1 over. 6 plus 1 is 7. Plus 7 is 14. Carry the 1 over. And then you have 2. So, for this experiment, Johnny's dad would have to go through 24,360 combinations of batteries to see which ones worked and which ones didn't from the box of 30. 24,360 combinations, all from multiplying the amount that is in the sample size after you take out one at a time. So that is for unlike objects. But let's see what happens when you have like objects. So for this example problem, I have 5 Lego figurines, 3 male figurines, and 2 female figurines. And I want to take a picture to display and post on my social media. So I want to find out an arrangement to put the 3 male figurines and the 2 female figurines together, and how many arrangements I would have of each. But since I have like objects, it would require a different equation. So let's set this up. First, we would set it up just like with unlike objects. We would figure out that number. And we have 5 figurines. So we would have to multiply 5. And once we take one out, it would be 4 times 3 times 2 times 1. 5 times 4 is going to give me 20. 20 times 3 is going to give me 60. 60 times 2 is going to give me 120. And then 120 times 1 is going to give me 120 different combinations for just the 5 figurines if they're unlike, if I just switch them through any pattern. But since they're like objects and we don't have to worry about the arrangement since there's two females and 3 males, we would need to divide this number by how many identicals they had. So, first we would take the 3 males. And we would figure out from that arrangement how many there would be. So, first we take 3 times 2 times 1. Right here. 3 times 2 is going to give me 6. 6 times 1 is going to give me 6. And that's my number down here. But what are we going to do with that number? Well, we have to multiply it by the permutations of the 2 female figurines. And with the 2 female figurines, that would be 2 times 1, which will give me 2. So, now that I have that, I would divide 120 by 2 times 6, which would give me 12. So, 120 divided by 12. And when I set that up, 12 right here gives me 1, and that leaves 0, which means I need to add a 0, and would give me 10 different arrangements I could pick for these Lego figurines. Whether it is set up with 2 males at the end, with the male on the end with the female, 2 females in between, or if I were to have all the males on the end, or 1 female in between males here. There would be 10 different arrangements. So that is what like objects. So there you have it. There's how you solve permutations with unlike objects and like objects, part of the fundamental counting principle. And it is a good way to figure out arrangements for different activities, whether you're trying to figure out how much of this object you have or how many arrangements of foods or fruits you could put together. It's a great way to figure out arrangements for sample sizes. So thank you so much for watching this video. I hope you have a wonderful day. Thank you so much.